was very young, when I was about, I think all the way up to the age of 5, I remember being very confused at school because basically the way we were taught at school in Rochester in Kent in England was we were taught everything by repetition, whether it was nursery rhymes or whatever we were doing, but also mathematics. I remember the incredible low point of my life when I was 5 was being told to repeat over and over, 1 times 1 is 1. Seemed a pretty pointless exercise to me. And actually, my mum and dad were really into being quite playful with maths. And I know in India, there's Vedic maths and there's the abacus system. And I was always very playful with maths. I thought of maths in a very fluid way. And my mum and dad knew Vedic maths as well. And so I was kind of really interested in the idea of being, I suppose, more inventive with the way I kind of did times tables. And I remember going around talking to other kids and trying to get them to learn different ways of multiplying numbers together. And for example, I don't know how many of you can do your times tables up to, say, just 30 in your head. Stick your hands up if you can do your times tables up to 30 in your head. Okay, so not many of you. So if I can teach you how to do that right now, in fact, very quickly. So let's do it. So you've got, now if you don't follow me, I'm going to go pretty fast, but if you don't follow me, play it back. So we've got two numbers. We've got 18 and we've got 14. You take the 4 of the smaller of the two numbers, take the 4, add it to the 18, gives you 22. Put a 0 at the end, gives you 220. Take the 2 unit numbers, multiply them together. 4 times 8 is 32. You add them together, so it's 32 plus 220 gives you 252. That's the answer. 18 times 14 is 252. If you do it now with two numbers in their 20s, we'll do 22 times 23. Again, take the unit number of the smaller of the two. 2 plus 23, add it onto the larger number. 2 plus 23 is 25. You double it this time. It's the first stage, and it's in its 20s, so you double it. So 25 times 2 is 50. Put a 0 at the end, you've got 500. Take the 2 and the 3, multiply them together, and you've got 6. And you end up with 506 when you add them together. So 22 times 23 is 506. So that's how you do it, all the way up to 30 times tables. And so it's actually about just being creative and not just simply being repetitive with things. And I felt the same way about music as well, because with Western classical music, and I was trained on the piano since a very young age, and I remember thinking, well, I don't just want to be stuck to the page the whole time. I don't just want to be reading sheet music. And I remember thinking that through my whole life. I was a jazz musician. I played lots of different things. I got into Indian classical music, listening to that a lot and listening to different ways in which people improvised. And I remember when I was working on a video game a few years ago, I was working on a game called Heavenly Sword. And in that video game, what happened was that I actually got the orchestra to play an Indian classical pattern, a North Indian classical pattern. Oh, they've started it, so I'm going to stop that. Okay. Right, so this Indian classical pattern is a 7-beat cycle, and you might know it as Rupak, and it's actually a Hindustani pattern, but I had it in 7/4 time, and they weren't getting the groove of it in the way they were playing. So I just kind of went up and helped them to do that just by explaining to the orchestra.
Combat situations, the music tends to be quite epic and has a lot of power to it. There's parts which involve Indian classical music. Sometimes Western classical orchestras are not so used to music that's completely rhythmically based. You have to really get into thinking beyond what is just written.
Okay, this rhythm is from an Indian classical time cycle. It's just a continuous rolling flavor.
I think definitely the music has a sense of excitement to it and an energy that infuses it with a sense of momentum. So that's really what I was after. To me now, PlayStation 3 and Heavenly Sword have kind of produced something that is more like an interactive film. But I never really thought it could get to this level.
So that's a very modern example of something I've written for an orchestra, but Thank you. A much older film that I worked on was a film called The Lodger, which is actually an old film, an old black and white film from 1927, which was directed by Alfred Hitchcock. And it was one of his very early movies. And I had to conduct the London Symphony Orchestra at the Barbican for this film. And originally, when they mechanically render the film, when they print the film, they do it by hand. And so every single time they print a copy of the film, it would change in terms of its length. So the first time I actually composed the music for the film, I had all the deceleration and the acceleration of the different tempo moments for different scenes. And then all of that had shifted round because when it was a much shorter film or a much longer film, I had to change all of that. And it was uneven as well. So I had to use calculus in order to actually get everything to work. And one scene I used calculus on in order to get the scene to work fluidly. Calculus, you might know, is the study of how curves, the area of curves, and also with integration and differentiation is about the instantaneous rate of change on any given moment on a curve. So all of that was very helpful in the way I approached the music for this next scene. But strangely enough, it's actually a love scene. And in this scene, it needs a certain type of emotion. So it's interesting that mathematics was what gave it its emotion in the end. Yes. So that's one example of, thank you. Now, with this next, with another production I scored the music for, it was, I was very excited by a mathematician, an Indian mathematician called Srinivasa Ramanujan, who actually was part of the Bengali Renaissance way back in the early part of the 20th century. And he was behind a lot of the thinking of string theory. And this is a man who was very playful with mathematics. And in a way, his mathematics actually inspired the art of the theatre. The production that I actually scored was called A Disappearing Number. And I think also there's a film about him. So it's interesting that his work as a mathematician inspired art. But with the next person that I'm going to talk about, Akram Khan, who's somebody I've worked with a great deal over time, he's a Kathak dancer, and he's somebody who uses art to inspire mathematics. So he uses the thinking of mathematics in the way he expresses himself as a dancer. And it's very interesting because I did a production with him at the Sadler's Wells Theatre, which was called Confluence. So you'll see various images of when we were actually doing Confluence together, and this is us just being playful on stage. And basically we had some musicians behind us, and we were just going through different ideas and trying out different kind of ways of looking at not only music and maths and dance and the ways they work together, but actually just celebrating our whole time of working together as two artists. And one of the musicians who was working with us at the time was the person to my left, which is Nicki Wells. So give a warm welcome. And one of the pieces we did on stage, and actually Nicki and I have done this many times, but we've last did it together at the Large Hadron Collider at CERN for another TEDx talk we did a couple of years ago. But but this is based on a pattern originally from Birju Maharaj, who's a very famous Kathak dancer, and the first part of it is from him, and the rest of it is something that I created as a kind of conversation in mathematics using combinations of tabla balls and also balls from Kathak and all kinds of different things, but using the mathematics of different forms. So we're going to do that now. एक दो तीन चार एक तक एक दो तक एक दो
तकिता एक दो तीन तकिता एक दो तीन चार तकिता एक दो तीन चार पाँच तकिता धा एक दो तीन चार पाँच तकिता धा एक दो तीन चार पाँच तकिता तकदा 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 जुम तकदा जुम 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 तकदा तकदा जुम तकदा तकदा da jum tere gede 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 taqda taqda da jum tere gede 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 taqda 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 da taqda da taqda da taqda da taqda da taqda tere gede 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 da tere gede da tere gede da tere gede da taqda 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 da da tere gede da tere gede da tere gede tere gede da tere gede da tere gede tere gede da tere gede da taqda da taqda da taqda da taqda da taqda da taqda.
Nicki Wells. Just to play you out, this is a piece that I wrote quite a long time ago, which is just based on pure knowledge, I guess, and it's kind of really about celebrating knowledge as opposed to and celebrating the fluidity of knowledge. And I guess that's what I've been getting at, is the idea that I think all knowledge should be fluid. You should be quite flexible in the way you approach science, as well as music or any art form. And it's about being creative and constantly looking for ways to be playful as well, and I think that's very important. So this piece is called Vidya. It's just about pure knowledge. Thank you. Thank you very much.